Okay, so today our objective is using proportions to solve problems. You're doing page 150, 1 through 50 odd. So a proportion is a statement of equality between two ratios. A ratio is like a fraction. The mathematical term for it is a ratio. So the way we solve a proportion is we multiply what's called the extremes, AD, times the means, BC. Okay, and it creates this statement of equality. Now, I know when you guys were in elementary school, you used to look at this and say, oh, I know this is times 4, and I can figure out that that's 12, right? But that doesn't always work, okay? In this case, it works, and they set you up with nice, friendly numbers when you're in elementary school, so you don't really have to use what's called cross products. So to solve a proportion, we take the extremes and we multiply them together, and we get 60. And then I'm multiplying my extremes, my means, and I get equals 5 times x is 5x. We divide both sides by 5, and x is equal to 12. Okay, why don't you guys pause the recording and try number 2. Go. I want you doing it in this method, doing cross products. What's the line going to look like, Julio? The next line, what?
It's going to look like 5x is equal to 210.
Good, 5x equals 210. And then what are we doing? Keep going, Roman.
Dividing by 5.
On both sides of the equation, and we get x equals 42. Now, I know that it probably would have been easier, Carter. It would have been easier if I had just gone, well, 5 times 6 is 30, so 7 times 6. Another thing we could have done is we could have reduced, we could have set it up like this. I could have done 5x equals 7 times 30. And if I don't want to divide 5 into 210, I could still just divide right here. And 5 goes into 5 once and into that 6 times, and x equals 42. So I could have done it that way. Sometimes when I have big numbers, I don't multiply them out. I just divide and see if there's a common factor somewhere. I can cross cancel. When we're multiplying over the equal sign, we call this cross products. Everybody say cross products.
Cross products.
Okay. Do you understand the difference between that versus when we were cross canceling? When you have something like this, 2/3 times. When we have something like this, we cross cancel over a multiplication sign. It goes once, it goes 4 times. It goes once, it goes once. We end up with 1/4. That's cross canceling. Okay? However, this is called cross product. Okay? Cross product. Everybody say that.
Cross product.
We're crossing, and product is the result of a multiplication. Okay? So not to get those confused. All right, so let's add a variable to it. Let's add a variable to it. What's this going to look like? How about TJ? What would this be when I multiply that across? What would it be? Okay, so he's saying to me 60x. Okay, so he's doing 30 times 2x is 60x. And continue, equals what? 15, good. So now what would I do to get the x alone? What would I do? Both sides by what? Okay. What am I doing to both sides, Carter? I'm going to divide both sides by 60 to get the x alone. Now, I have to reduce that. I have to reduce that. So what would I do to reduce that? What number divides into numerator, denominator? Ayla. 15 goes into 15 one time and into 60 4 times, so my answer is 1/4. Okay, you want to try the next one? Okay, pause the recording and try the next one. All right, let's try it now. How about Matthew? What's the first line going to look like?
20 equals 6x.
Okay, let's go first left to right. So before you do any multiplying here, what's it going to be? 3.
3 parentheses 2x.
We say times the quantity.
3 times the quantity is 2x plus 1.
Perfect. Equals, now you can just multiply it. 20. Okay, what would I do first, Matthew? We're going to distribute, and I do 3 times 2x, which is 6x. And I do 3 times 1. Are people forgetting that? I think they are on their test. Many people forgot to distribute to the second number. And then I'm subtracting 3. I get 6x equals 17. Divide by 6, and x equals 17 over 6. Yes?
On the test, do you want us to do the 3 and the distribute?
Well, in this case, because there's more, don't do the distributing in your head, like at the very least, because eventually we're going to have fractions, numerator, denominator. We're going to have variables with exponents, numerator, denominator. So write that stuff down, then do your distributing. You have to remember, we're starting very simple right now, and we're going to end, it'll be very complex, almost like in what they do in Algebra 2. So we're building up for later. So if there's some distributing, I do want you to write it like this. If it's just 3 times 5, you don't need to write 3 times 5. You can just multiply it. All right, questions? Okay. I'm going to pass on this for right now, and we'll come back to it. Okay, I'll come right here. All right. So what this is really saying is there's a lot of different ways to set up a proportion. So you can see, like right here, notice x and 6 are both talking about the height. Okay? And 25 and 5 are both talking about the base. The first fraction refers to the tree. And this, you don't have to write this down. And the second fraction refers to the man. So as long as you're straight all the way across, all the way up and down, that's okay. You'll see x and 6. This kind of refers to, this is the height. And this is the base. This is the tree. And this is the man. Whereas if you look at some of these, notice x represents the height and this represents the base. Do you see how it's not the same all the way across? This is the height and this is the base, but it's not like this whole thing, the 25 is the tree and this is the man. Do you see it's not the same going up and down? So that's a bad proportion. Do you understand the idea? That it really kind of needs to be the same in each column. So let's go to, say, a word problem. Not this word problem. All right, so word problems. Proportion word problems. tonight they're going to be pretty easy because we're solving proportions, so you likely will know this. But how do you identify that it's a proportion word problem when it's mixed in with other things on a standardized test? Carter.
If it says like how many can be made with a different amount than before.
Okay, what else?
If it has like cups and cookies are two different things.
Right.
So like compare it.
Keep going. Yep.
If you could do this in this amount of time, how much would you do in this amount of time?
Okay, yes.
If you use different measurements.
Okay, different measurements, but notice what they do with a proportion is they give you three different quantities, and the fourth is how much, or what is it? So when they give you three quantities and the fourth is how much is it, then you usually can set this up. Now, words only, I want no numbers. What am I comparing here? Carter?
Flour and cookies.
Okay. I like to say cups, but flour's the same thing. That would work as long I don't care what you use as long as you're using the same thing. Cups to cookies. And the first fraction they give us is what? What fraction do they give us, Carter?
6/54.
6 cups to 54 cookies. And then that equals, where does the 10 go? Numerator or denominator? Numerator, that's right. So 10, because I have my cups up top. And so it's how many cookies, that becomes my x. And so then I'm going to do my cross products. That equals 540. And I'm doing my other cross product, equals 6x. I divide both sides by 6, and x is equal to 90. Now, I don't care. You could have set it up cookies to cups. There's no order here. Okay? And if I set it up that way, then I'm doing 54 over 6 to 6 cups. And then I have 10 goes in the denominator, and this becomes my, right? And then we're doing 6x equals 540. Divide by 6. X equals 9. So do you see, it doesn't matter how you set it up. As long as you set it up. Did I do something wrong? 90. Okay, sorry. As long as you set it up, notice it's the same all the way across, the same all the way across, same all the way across, all the way across. Yes, Rami?
Can't you do 6 over 10 equals 54 over x?
6 over 10.
No, it's x over 54.
6, okay, so he's doing 6 over 10. Let's try it. So 6 over 10 equals what?
54 over x. No,
because the cookies are.
Yeah, it's going to work. Because look, right here we're setting this up. I don't want you to be in the habit. That's kind of going back to that last slide I have. But I want you to be in the habit to set it up in words first. And going across should be the same. So how's he setting up? What is the pattern? This 6 to 10 is your cups to cookies. Okay, and this is the I don't know how to describe this in words.
it helps me like categorize them, like kind of see it better. I don't know.
I know, but I would like you to do it like this. Set up your category right here. Got it? Okay. So, I mean, it would, because that last slide said, as long as you're setting it across and up and down, but how he's setting it up is through up and down. Okay? Somebody also said to me, so if I have this, so if we're doing cups to cookies, right? And then I have 10 to x. Can I simplify the first fraction? Absolutely. 6 goes into 6 once and into 9, so that's 1 over 9 equals 10 over x. Now we can do 90 equals x.
Wow.
So you can simplify the fraction before. Reduce that fraction. Okay, so my unknown, we should always identify our unknown. I'm gonna say, okay, that's it for the lesson. Here's a practice problem. You can pause the recording and try it. Identify your unknown this time. By the way, what is my unknown?
Widgets.
Okay.
How many you can reproduce the total?
Right, how many widgets? So we would say, you know, X is the number of widgets. Pause it. Now check your results. And that is the lesson.